Welcome to the robotics class for January the 27th. This is the first class that I'm recording, even though it's not the first class. And the reason that I'm recording it is because we're going to go over some things later in the period here that for some of you will be brand new. Now, I realize for some of you, this is stuff that you've done before, but for others of you, this is going to be brand new. And I think that you will appreciate having a recording of it on Canvas so that you can go back and watch the recording again if you need it. Okay, so before we talk about the new stuff, let's quickly talk about the old stuff. The assignment that was due today was for you guys to submit a copy of a Tinkercad creation you made, where the Arduino, okay, so this is a real Arduino. So what you did was you had a Tinkercad simulated Arduino, and you had a Tinkercad simulated little baby motor like this. And so Tinkercad can only put out 5 volts. And I don't think we've ever talked about, we haven't yet talked about current. Not today, but later, we're going to talk about current and what it is and how you measure it and how much it can put out. So it turns out that the Tinkercad cannot put out very much current at all. This motor right here is pretty much right on the limit of what it can do. So if we try to run any motor that's any bigger than that, if we try to run a motor like this, or even a motor like this is kind of iffy, the Arduino would not be capable of putting out enough voltage and or current. And so we talked about how to get around that a little bit, and we're going to talk more about it later. But for last night's homework, we were assuming that we were working with a baby motor that where the Arduino was able to put out enough voltage and current. So we can just hook up the baby motor directly to the Arduino, and it can get its power right straight from the Arduino. And so your job, okay, here she comes, good. Hang on a sec, let me let her in. Okay, now everybody's here. Okay, so, and by the way, Catherine, just so you're aware, we are recording this. So be careful not to turn on your camera. And if you say anything, be aware that what you're saying is being recorded, please. Okay, so in the assignment that was due today, you showed me that you could take a simulated Arduino and a simulated motor and hook them up together. And then the motor could run at different speeds. And the way that we did that, I'm sure, I trust you remember, is the Arduino does not lower the voltage when it runs, when it wants the motor to run at half speed, it does not lower the voltage level to half of the voltage. What it does is it uses what we call pulse width modulation. And so it's super, super important you understand pulse width modulation, because boy, is that ever used a lot in robotics. Okay, so let me just show you mine. Let me go into Desmos, not Desmos, Tinkercad is where I want to go. Okay, so the ones that you guys submitted were pretty similar to mine. So let's just talk about it. And the reason I want to talk about it is because what we're going to do next is a slightly different twist on it. But you need to fully understand last night's homework, otherwise you'll have no hope of understanding tonight's homework. Okay, so as you've probably discovered, Tinkercad takes a little while to come on. That's kind of annoying. And when it comes on in the 3D drawing mode. So we need to switch it over to circuit mode. And then we need to wait a little while for it to come on. Especially for me, I've got so many circuits stored there that it really takes a long time for me. Hopefully it doesn't take quite so long for you guys. All right, so motor control directly from the Arduino. Okay, so let's go in and tinker that one. I think I may have changed this one a little bit. I may have added in a few things that you guys don't have. Do, 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 do. Do, 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 do. Do, 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 do. There we go. Okay. All right. Yeah. So this one, I made a few modifications to this one. I forgot I'd made those modifications. Oh, well. Um, okay. So what I did is a little different than you. I've added in this knob here. And so in your assignment, you did not have the knob. But, maybe this could be good. All right, so let's take a look at what I've done. So let's start the simulation. And okay, so the oscilloscope here, I've got it set so that the time per division is 1 millisecond. Maybe we should talk about this real briefly here. Okay, you can change the time per division. So if I make the time division to be 10 milliseconds, okay, you don't really see any detail. So that's not a good setting. If I have it be 1 millisecond, that's good. What if I make it 0.1 milliseconds? Okay, then come on, is it not? Oh, it doesn't want to let me do that. Okay, all right, sorry. So for what we're doing here, let's stick with 1 millisecond. Okay, so what that means is that from each square that we go horizontally is 1 millisecond. All right, so the way I've got this set right now, the Arduino is doing a pulse width modulation. So it's giving full voltage for a little bit, and then it's going down to half voltage for a little bit, and then full voltage for a little bit. And so what you guys did was you had your circuits run like this. Now I modified mine a little bit. I've got this knob here. So by changing the knob, it looks like my simulations, let me tell you what, my simulations kind of mess up. This happens sometimes in Tinkercad. If your Tinkercad starts acting weird, go up here and just reload it, and then it'll be fine. Tinkercad's a great program, but it does have a few little bugs in it. And it's a free program, so hey, it's hard to complain. But if it behaves weird, just reload the page and then sit there and sing the do 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 again while you're waiting. Boy, it's really slow today, even slower than normal. Okay, so let's try this again. So I'm going to zoom in. Okay, so I'm going to start my simulation. Okay, notice the pulse width is a little bit lower this time. So I've got it set up so that I can turn a knob, and depending on what knob setting it is, the pulses either get wider or narrower. Okay, so this is a nice way. Ultimately, I'm going to have you guys do one of these, but not today. Notice the speed on the motor there. Let's zoom in a bit there. Okay, so the motor speed right now is right around 2,500 RPM or so. If I turn this down here, you see the motor slows down quite a bit. If I turn the knob up a bit, the motor speeds up a lot. Now the motor is running at full speed. Okay. So ultimately, you guys are going to do something like that too. So what you did in the homework tonight was you just had one setting. And so if you wanted to change the speed of the motor, what you had to do is you had to come in and you had to play with the number that you put in here. But I've done it a little differently here. Okay, so ultimately, this is where I'm going to want you guys to go, is I'm going to want you to do this. But before you can do that, you need to learn a few things. Okay, so let me show you a circuit that I'm going to want you guys to duplicate for tonight's homework. Let's go back here, and this means we have to wait again while Tinkercad does its thing here. I'm going to go back into my Tinkercad main page. Okay, so there are two different circuits that I'm going to have you guys make today. So the first one is going to be this one. I call it a 5-speed motor driver. You will see what I mean by that. Let's see. Dum, dum, dum. Sure would be nice if Tinkercad would boot up faster. But like I say, hey, it's a free program. Can't complain too much if it's free. Okay, come on. Boy, it's not usually this slow. Okay, here we go. Okay, so here's the deal. This is what I want you guys to create today. Now, there's a bunch of things in here that for some of you, it's brand new. Others of you, not so much. Okay, so I've got a motor connected up to an Arduino. And so let's see what, well, actually, let me show you first what it does. So I'm going to start my simulation going. Okay, and so when I start it, oh, so Eric is asking me, can you learn how to solder on Friday? Actually, yes, Eric, I would like to do some soldering on Friday. And thank you for reminding me. We do need to talk about Friday. But let me hold off on that for a sec. Okay, so what you guys are going to do for your homework tonight is you're going to build a circuit that's going to look like this. My simulation is going right now, but you'll notice the motor is not turning and the oscilloscope is showing that nothing's happening there. So I have these push buttons here and I want you to see. So I'm going to come over here and I'm going to click on this button and I'm going to hold my finger down. So ready, here goes. So I'm clicking on it. And now what you'll see is the motor is turning at a number that's approximately 1000 RPM. In fact, let me zoom in a bit here. Okay. So you can see the number. Well, when I let go of the button, it goes back to 0 again. So as long as I hold the button down, the motor is turning at a speed that is approximately 1000 RPM. Now it jumps around a little bit, as you can see. So it'll go a little bit over 1000 for a second or two, and then it'll jump a little under 1000. But on average, the speed there is about 1000 RPM. And if you look at the pulse width modulation, you can see that the pulse is on for approximately 1/5 of the second, and then off for approximately 4/5. And by the way, not a second, it's a millisecond. Okay, now this second button, when I push the second button, you'll see that the motor runs at approximately 2000 RPM. And then when I let my finger off, it goes to 0. Now the oscilloscope, there's a little bit of a lag between when the signal goes to 0. It takes a second or two before the oscilloscope registers it, but you'll notice the motor stops pretty quickly. Okay, so I'm sure you guys can guess what this next button is going to do. When I push it, okay, so it's going at approximately 3000 RPM, and you notice that the pulses are a little bit wider there. Now I'm going to go over here and at 4000 RPM, pulses are even wider still. And now I come up here and now this one's going to take me at about 5000 RPM. And now you see the pulses are really wide. Okay, so this is a manual motor controller. And when I say manual, I mean we control how fast the motor goes depending on which buttons we push. All right. Now, so you guys are going to have to make something like this for your homework tonight. Let's follow the path of the electricity. Let's make sure that we see what happens. So when I push the button, what happens is, why is it on annotation? Why is it not coming on? Okay, here we go. All right, so I have chosen to use pin number 6. You can choose any pin you want. So the electricity comes out, it goes through here, and it comes into the motor. And the oscilloscope is also hooked up there, so the oscilloscope will tell me what's going in the motor. So it runs through the motor here, and let me switch to black ink here. So electricity that's coming into the motor, I like it to be red. And when it leaves the motor, it's going to come out, and it's going to go through this wire, and it's going to the thing that's called ground. All right, so the electricity is coming through the motor, but it comes in pulses because that's how we control motor speed, is by using what we call pulse width modulation. So if I want the motor to run slowly, I push this button. And so it comes in a bunch of very short pulses. If I want it to be a little faster, I push this button and the pulses get a little wider. If I want it faster, I push this button, wider still, and then wider still with this one. Okay. And then the last one here is this one. So now the pulses are really wide. So the motor runs at the higher speed there. Okay, so what we've done here is we've programmed the Arduino to put out the voltage in little pulses. And based on what you guys did for the homework that you turned in today, it looks to me like you guys understand how to tell the Arduino to do that. So here comes the new stuff. Let me stop the simulation here. Whoops, I don't want to finish. Sorry, I hit the button. Okay. So here's the new stuff. And let me get rid of all this. Okay. These pins down on the bottom, we haven't talked about these before. So you need to understand how these work. This pin right here, labeled 5 volts. So that is like a 5-volt battery. That pin is always turned on. You couldn't turn that pin off if you wanted to. There is always, always, always a constant voltage of 5 volts on that pin. This pin right here is ground. So it's just like the one up on top. It's basically the negative side of the battery. And it's always negative. You couldn't change that if you wanted to. All right. So let's see how the electricity flows. So I've got it set up so that I've got 5 volts of electricity coming and it goes into this switch. And the way these switches work is that the left side is always connected. So if I've got 5 volts there, I'm also going to have 5 volts here and 5 volts here and 5 volts here and 5 volts here. So the left side of my switches here, they always have 5 volts of electricity on them, regardless of, whether they're being pushed or not. Now, the way these switches work is that the left side of the switch and the right side of the switch are only electrically connected when I push the button. And then when I take my finger off the button, they stop being connected. Okay, so as long as I'm not pushing any buttons, the electricity comes here and here and here and here and here, but it cannot go anywhere because the button is not being pushed. So let me switch to a different color pen here. So if I push, in fact, tell you what, let's clean up my drawing here. So let's focus our attention on this button right here. So if I push this button, then the electricity can now go from the left side to the right side. And so now the electricity can flow into this pin right here, A0. Okay. So if I'm not pushing the button, there is not going to be any voltage on the A0 pin. If I do push the button, there will be voltage on the A0 pin. And then what I can do is I can program the Arduino. I can tell it to look at the A0 pin. If it sees voltage on the A0 pin, then it should pulse the engine with a bunch of short pulses so that the engine runs slowly. Okay, and then same thing with this one right here. If I push this button, then what's going to happen is the A1 pin will see voltage. If I push this button, then the A2 pin will see voltage, and so forth and so on. So that should be relatively straightforward. The thing that might not be so straightforward is, what are these guys right here? And why are they there? Okay, now I know that some of you guys know the answer here. So would one of you please unmute yourself and tell me, what are those things that I just circled? What are they?
A pull down resistor.
Very good. Okay, so it's a resistor, and I have got it hooked up in a way that it's called a pull down resistor. So, I mean, if I ask you what this component is, it's a resistor. It could be a pull up resistor, it could be a pull down resistor. Don't worry about that for right now. If I ask you what it is, just say it's a resistor. Now, the way that I've got it hooked up is a very special way, which, as Zane said, is called a pull down resistor. And there's an important reason why we need that. So think about this. Let's suppose that I've pushed this button right here. Okay, so so the electricity comes out here, goes through here. The electricity comes in here. So now I've got electricity on the A1 pin because I'm holding the button down. What happens when I let go of the button? Okay, so if I let go of the button, so let's see, hang on a sec here. So before I let go of the button, I had a whole bunch of electricity on this line. When I let go of the button, what happens to the electricity? Now, some of you might think that the electricity will go into the Arduino and it'll all disappear, but that's not the way the Arduino works. Electricity does not actually go into the Arduino. All that happens is the Arduino looks at the A1 pin to see if there is electrical pressure there, but it does not let the electricity actually come into the Arduino. Is like a little door. Imagine that there's a door there labeled A1. And so the door is closed so that nothing can come in, but there's a little pressure sensor on the door. So if there's pressure on the door, we know it. If there's not pressure on the door, we know it. But the door is closed. The electricity cannot actually come in. So when I take my finger off the button, we've still got all this electrical pressure on this line here. And so the Arduino, when it looks at the pressure sensor on the door to see if there's voltage, when I say voltage and pressure, I'm going to use those two terms interchangeably because that's what voltage is. It's electrical pressure. Okay. So when I take my finger off the button, the Arduino might still think that there's pressure on the door. And so it might keep running the engine, even though I don't want it to run the engine. So I need to have what you might want to call a bleed valve. Okay. I need to have some way to let that electrical pressure bleed off so that the pressure goes to zero when I take my finger off the button. And so that is what this other line over here is. You can call this the pressure relief valve. You call it the bleed valve. Okay, so what happens is that the electricity comes in here, comes around here, comes here, goes, if I'm pushing the button, it goes through here, and then it builds up pressure here, but it actually cannot go into the Arduino. It just builds up pressure, but it can go through here. The ground pin does allow electricity to flow in it. Think of the ground pin as being a door where the door is open, right? So it does allow electricity to flow in here. Okay, so when I push the button, then electricity comes through here. Now, if I didn't have a resistor, so yeah, let me clear. So if this resistor was not here, I would have a problem. All of the electricity that's coming in here, I want it to build up a lot of pressure here. Well, it won't be able to because if I don't have a resistor, all of my electricity is going to bleed to ground and I'm not going to get high pressure over here where I want it to be. So I need to have something here that slows the electricity down. I don't want to completely stop the electricity. I do want electricity to flow through it, but I want to slow it down so that I can build up a lot of high pressure over on this side right here. Okay, so this resistor is a very, very important thing. If it wasn't there, I would never get the pressure here that I want. And so when I ask the Arduino, is there pressure on the A1 pin? Even though I've got the button pushed, it's going to say no. But because I've got the resistor here, then when I push the button, I will get a bunch of pressure built up on here. Now, it may not be the full 5 volts of pressure because some of the pressure, my picture here is getting to, so this 5 volts here, that's a measure of how much pressure I have. Okay, so because I've got this bleed line here, the total pressure that I got on this line is probably not going to be the full 5 volts. I'm going to lose a little bit of pressure here. But as long as I keep this resistor a pretty big, with a reasonable amount of resistance, I'll still have close to 5 volts. It might be 4.9 or it might be 4.8, but still it'll be close to 5 volts, and that's okay. All right. So if I didn't have these pull down resistors here, then hopefully you guys realize that what's going to happen is when I take my finger off the button, the Arduino is still going to think that there's pressure on those pins, and so it's going to keep the motor running when in fact it should stop. Okay. So those of you that took the Robotics 1 class with Mr. Webster, these are the kind of little details that I'm willing to bet you didn't talk about, right? Can you guys type into the chat box? Well, actually, first off, how many of you even took Robotics 1 with Mr. Webster? I know that many of you did not. Can you please type in the chat box in a private message, say yes if you took the Robotics 1 class, say no if you did not take the Robotics 1 class. Okay, so I'm seeing about half and half. Okay, actually, yeah, okay, yeah, it's about half and half. Okay, so when you took Robotics 1, this is a little detail that you didn't need to worry about because you were using pre-made robots where they already took care of all the details for you. But now this is the Robotics 2 class. We need to worry about these kinds of things. Okay. So hopefully now you understand why I put these resistors there. And Zane was correct in recognizing that when I hook up a resistor like this, we call this a pull down resistor. Now I could have hooked it up in another way. I could have hooked it up to where it's a pull up resistor, but let's not go there right now. I don't want to hit you with too much information all at once. Okay, so hopefully you guys now understand the hardware and why I've hooked up the hardware the way that I did. Now, the question is, how do I program the Arduino to make it do what I want? Okay. So I've got my simulation running right now. So how do I program the Arduino so that when I push this button, I get a pulse width that's approximately half, up for half the time, down for the half the time. And when I push this button, then I get a different pattern. So it's only up for 1/5 of the time and it's down for 4/5 of the time. How do I program the Arduino to do that? Can one of you unmute yourself and tell me how I do that? Okay. All right. Well, tell you what, let's just take a look at how I did it. So let's click on code and let's pull it over here. Okay. All right. So I used a new command that we have not yet used before. Let me pull it over here and let's zoom down so make a little bit here. So over here, we've got the different categories that we can choose from, right? So we got, up until now, we've been using the input and output commands, actually mostly the output commands. So what we can do is we can pull in a command here that says set pin whatever. Okay, so we can say set pin whatever, whatever we want, and we can set it to high or we can set it to low, right? We've used that one. And then when we want to use pulse width modulation, instead of using that pin, what we do is we use this pin over here, so that instead of only having two choices, high and low, we can actually give it a number. So if we want it to be full on, you guys remember what is the number that I give it to make it be full on? Can somebody unmute yourself and tell me?
255.
Very good. So full on equals 255. And then off would of course be 0. And then any number in between will be some fraction of that. Okay, so let's suppose I only want it to be half on. So I want to run the motor at half speed. Okay, so that would be half of 255. Let's say it's about 128. Okay, so what I can do then is I just come here and I type in 128. Okay, and so that will tell the Arduino to pulse width modulate, so that if I were to look at the voltage, then the voltage is a function of time, I would find that it's on for half of the time and off for half the time, on for half the time, off for half the time. Okay, so my drawings aren't very good. So use your imagination and pretend that that's on for half the time, off for half the time. That's what this number means. Okay. Now, one thing, I don't remember if I said this last time, and this is important to say. Look at my choices for pins. Do you notice something interesting? My choices is much more limited this time than it was before. If I'm going to use this mode, which by the way, we call this analog mode. If I'm going to use analog mode, I can't use any of the pins I want. I have to use only pins 3, 5, 6, 9, 10, or 11. If I want to use pin 4 for analog mode, I can't. It won't let me do that. I don't think we talked about this last time. Let's take a minute and talk about it now. This is important. If I come over here, if I look at these pins, do you notice some of the pins have little squiggles by them and some of them don't? So why is my annotation not wanting to come on? Okay. Notice the pins that have the squiggles by them. So 3, 5, 6, 9, 10, 11. What a funny coincidence. Those are the ones that that we had the option of. Okay, so these pins are what we call the PWM pins. If I want to use analog mode, if I want to use pulse width modulation, I can only use these pins. If I want to use pin number 7 for pulse width modulation, too bad, won't work. I can only use the PWM pins. Okay, so that's the reason why it is that when I click on the code here and I come to this guy, he's only going to let me select the PWM pins. He's not going to let me select the other pins. Okay, so let's put that down here. Okay, so if we come up to control, this is where we get the commands like where we say, wait for 1 second or whatever. Well, there's a nifty thing in here called if. Okay, so what I can do is I can tell it to set pin whatever to 128, but only do it if a certain thing is true. And so let's take a look at what I've done here. So you can see right here, and let me turn on annotation so I can do this. So this right here is one if statement. And this over here is a completely different if statement, and so forth and so on. So what I've said is that if, when I read analog pin A0, if I get a value that is greater than 500, then and only then I want to set pin 6 to 45. So 45 is approximately 1/5 of 255. Not exactly, but approximately, right? And so that means that it's going to run at 1/5 speed. And this is going to run at 2/5 speed. And this is going to run at 3/5 speed. But only if I have the appropriate button pushed. Now, what is this 500? Where did I get the 500 from? Well, this is something that you just need to know. And this is the reason why I'm recording this. When I look at these pins on the bottom here, so let's go down to here. Oops, sorry, I didn't want to do that. Okay, there we go. I'm a little trouble moving my thing around here. There we go. Okay. So these input pins, they have a special way that they operate. Okay. When they read the voltage, they don't just tell you what the voltage is. So let's suppose that I've got this button pushed. So I've got 5 volts coming through here, going in here. And let's suppose that this resistor isn't here. So the voltage that this pin will be feeling if I have the button pushed will be 5 volts. But if I were to ask the Arduino, what number do you see when you look at pin A1? It's not going to tell me that it sees 5 volts. For reasons that I don't want to go into right now, if there are 5 volts on the input pin, the Arduino does not see it as 5. The Arduino sees it as 1028. Now, if you guys have taken Mr. Webster's class, you know about binary. And you know there's a reason why we use this special number of 1028 is because it's a binary multiple of 2. But I don't want to go into all the details right now. So if I'm pushing this button and then I ask the Arduino, what number are you seeing on A1? If this resistor wasn't here, it would report back to me a number of 1028. So if I come in here, let me, okay. So if I were to give it this command where I say read analog pin whatever here, so let me, okay. So if I tell the Arduino that I want to read analog pin whatever it is, if there are 5 volts on the pin, then the number that it would report back would be 1028. Okay, so the reason I chose a number that's approximately 1/2 of that is because I do have a resistor in my circuit here. These resistors that we call the pull down resistors here, some of the voltage that we want to be on here is bleeding through here. So because of this resistor, the pressure that I get here is not really going to be 5. It's going to be some number a little bit less than 5. So what I did was I just said, okay, let's just call it half approximately. And so if I'm pushing this button, then if I ask it to read analog A1, it will definitely give me a number that's greater than 500. It'll give me a number close to 1000. If I take my finger off of the button, then the electricity is all going to go through my bleed resistor and into the ground. And then if I ask the Arduino to tell me what number it sees on A1, it'll tell me that the number it sees is 0. So now, hopefully you can understand, whoops, that wasn't what I wanted to do. Hang on a sec. Okay. All right, so let's go to code here. So now hopefully you can understand why I've written my code the way that I have. So let's go back, okay, up at the top here. All right. So what I'm telling the Arduino is I'm telling it to read analog pin A0. That's the one on the left. If the number that it sees is greater than 500, which is about, halfway between full on and full off, then and only then set pin 6 to 45, which would correspond to about 1/5 of the speed. Now, if I'm not pushing A0, then the number that it gives me when it reads it will be 0, so it will not do this. If I'm pushing A1, then it'll set pin to 90. If I'm pushing A2, then it'll set the pin to 140, and so forth and so on. So does this make sense here? Can you now understand why it is that my machine does what I want it to do? Okay, so what I want you guys to do is I want you to type in the chat box. I want you to say yes if this makes sense to you. If you have a question, so yes if this makes sense, and say no if it doesn't. Okay, I'm seeing a lot of yeses. Not seeing any no's. Okay, good. All right. So your homework assignment tonight, at least the first part of your homework assignment, is to is basically duplicate what I've got there. And in fact, if you go into Canvas and you read what I've said here, let's go into the robotics page. All right. Okay, so let's click on the robotics page. And we'll click on modules. Or you can click on this icon down here. They both take you to the same place. Okay. And now let's go down here. So tonight's homework is this one. A small motor powered by an Arduino. And there's two different ways. One way is use a manual 5-speed button control. And then the other one I'm going to talk about in a minute, that's the autonomous ramp up and down. Okay, so if I click on this one, so here is your assignment, at least here's part one of your assignment for tonight. So I want you to use Tinkercad to create two different Arduino-based motor control circuits. Okay, in both cases, I want you to include an oscilloscope because I want to be able to see the pulse width modulation. So in the circuit that we just did, there should be 5 push buttons. And I want you to make it so when the first button is pushed, I want the motor to run at about 1000 RPM. Now, the reason I say about is because as you saw, the motor jumps around a little bit, okay? So don't worry if it jumps around a little bit. I just want the average to be at 1000 RPM. If you've got the second button pushed, then I want it to be 2000 RPM. Okay, if the third button is pushed, 3000. If the fourth button is pushed, I want it to be 4000. And when the fifth button is pushed, I want it to be 5000. So when you do set pin 6 to some number, you're probably going to have to play around a little bit with that number. I mean, you can calculate what number you think is going to be right, but don't be surprised if when you actually run the motor, sometimes it runs a little faster, a little bit slower than what you anticipated. So just go in and just do trial and error. And so when you push button number 1, okay, if you find out that the motor is running a little bit slower than you want it to, just go into your code and change the number, just make it be a little bit higher. And just keep playing with it until it gives you the right speed. Okay, now with first robotics, when you guys did the rules, when you told me that you understood what the rules were, then hopefully you understand that in first robotics, there's 2 ways that we control the robot. One way is the way that we call tele-op, and the other way is the way that we call autonomous. Okay. Okay. So tele-op is when you have a human driver, and autonomous is when the robot robot self drives. Okay, so no human. All right, so I want you to kind of simulate that in tonight's homework. The first circuit that you make is the one that's going to be kind of like tele-op. So the robot will run at whatever speed you tell it to, depending on which button you push. But the second assignment here, okay, this one is more like the autonomous mode. So in the second circuit, I don't want there to be any buttons, okay? So in the second circuit, there will be no buttons. What happens is you're going to program the robot so that it just automatically does it on its own. So when you push the simulation button, here, let me get rid of these things. Okay, oops, okay. So when you push the simulation button, I want the motor to run autonomously. So the first thing that it should do is it should ramp up slowly to full speed. I want it to take about 3 seconds to go from 0 to full speed. So it's going to slowly ramp up. Then I want it to stay at full speed for about 3 seconds. And then I want it to slowly ramp back down to 0. I don't want it to go instantly to 0. I want it to ramp to 0. And I want it to take about 3 seconds to do the ramp down. Then I want it to stay at 0 for 3 seconds. And then I want to just repeat that cycle over and over and over and over again. Okay. Now, this requires some knowledge of programming. And I realize that many of you know how to do this, but some of you don't. So let me show you how I did it. The way that I did it is not the only way that it could be done, but I think it's the most straightforward way. And again, remember that everything that I'm showing you now is being recorded. So when you do this as a homework assignment, if you don't remember everything about how to do it, come back and watch the recording. And then you'll hopefully see how to do it. So I'm waiting here. Okay. All right. So this circuit right here, the one that I've called the ramp up and ramp down motor controller, this is the one. And so you guys, I'm okay with you basically copying what I've done here. Okay, so I've clicked that. Let's see how that one works. And should I sing the song again? Okay, well, here goes. Do, 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 do. Do, 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 do. Do, 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 do. Boy, I don't usually get this far along in the song before it comes up. Do, 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 do. Oh my goodness, I almost never finish the song. Tinkercad is running really slowly today. Oh, this is annoying. Hopefully it'll run faster for you guys. Maybe there's a lot of people all running Tinkercad all at the same time. There's so many. Oh, here we go. Okay, yes. All right. So first off, let's look at the hardware. Okay, so you'll notice no buttons because we don't need buttons. The Arduino is going to control the robot all by itself. It doesn't need a human driving it. It's going to drive itself. Okay, so I've got the motor hooked up to pin 6, just like I did before. Now you guys don't have to use pin 6 if you don't want to. Just make sure that you use a pin that's capable of pulse width modulation. So 3, 5, 6, 9, 10, 11. You can use those. Don't use the pin that doesn't have the little squiggle by it. Okay. All right. So first off, let's make sure that this thing actually does what I wanted it to do. So let's click the simulation and let's see it start. Okay. So it takes a few seconds to start up. Here it goes. So you look at that. So it starts off with narrow pulses. Notice the engine's running more slowly. And then the pulses get wider and wider and wider. Okay, now we're running at full speed. Oops. There's a bug in my code. I forgot to tell it to stay at full speed for 3 seconds. Okay, so we'll need to fix that bug. This will be good. Okay, so now it's down at 0 speed. Now it should stay at 0 for 3 seconds, but it didn't. So we're going to have to change my code. But the ramp up and ramp down, that's approximately right. It's okay. So it's just going to keep on ramping up and ramping down, ramping up and ramping down. So how did I do that? Well, those of you that have had a programming class, you already know. But the rest of you, here is how I did it. So this is my code right here. So what I'm doing is I'm using a new code block that we have never used before. Let me come over here so let's set that aside. So if you come into the control block here, you'll see I've got a bunch of blocks here, some of which I haven't used before. If I come down to the bottom, you'll see I have a block here that says count. And what I can do is I can count either up or down. and I can count by whatever I want. And I can start wherever I want and I can end wherever I want. Okay, so let me get rid of that. So what I've done here is I've got one of these count blocks. And so what I'm telling it to do is I'm telling it to count up, and it's going to count by tens. So it's not going to go 1, 2, 3, 4. It's going to go 10, 20, 30, 40. Okay. J is just a variable. And so what it's going to do, it's going to start and it's going to say, and it's going to, let me get the annotation going here. So it's going to start with this number and it's going to say J equals 0. And then it's going to come in here and it's going to set pin 6 to whatever number J happens to be equal to. So which is going to be 0. All right. And then what's it going to do? It's going to wait for a certain amount of time. Now, what I've done is I've told it to wait for 0.1 seconds. I could have told it to wait longer. This is the thing that determines how quickly it ramps up or how quickly it ramps down. So I told it to wait for 1 second, or I'm sorry, 0.1 seconds. Okay, so when it gets to the end of this thing here, notice how it's got a little arrow here that says go back up again. So then it takes J, which used to be 0, but it says, okay, not going to be 0 anymore. Now it's going to be 10. And so now when it comes, so it's going to keep repeating this over and over and over and over again. So the second time it comes through here, J is going to be 10. So it's going to set pin 6 to 10. And it's going to wait for 1/10 of a second. Then it's come to the bottom, and then it's going to bounce up here to the top again. And the third time it does it, J is going to be 20. And then it's going to wait for 1/10 of a second. And then it's going to come here and bounce up again. And then this time J is going to be 30, and then 40, and then 50, and then so forth and so on. And it's just going to keep going through this loop. And each time it goes through the loop, it keeps increasing J until it gets to 250. When it gets to 250, then it's going to stop. And it's going to leave this loop and it's going to go down to the next command in the sequence. Okay, so the next command in the sequence is I told it to wait for yet another 0.1 seconds. Okay, and here, this is the thing that I did wrong, because remember how I told it that after it ramps up, I want it to wait for 3 seconds. So now is a good time to fix that. Okay, so let's change that. So when it gets to the top here, I want it to wait for 3 seconds. And then now you see what I'm doing down here is this time it's counting down. So it starts at 250 and it counts down and the increment is 10 and it keeps, and it does the same thing it did before until it gets to 0. And so there we are. And so now let me change this guy right here. So I wanted that to be 3 seconds. Okay, so here, this is the code that should do what we want. And so now I fixed those 2 little bugs that I had in my code. Let's see if it works. Let's start the simulation. Give it a second to start up. And here goes. Okay, so it's ramping up. It's ramping up slowly. Maybe a little bit too slowly. I might want to come back and fix that, but that's close enough. Okay, so it's at full speed. Now it's going to run at full speed for 3 seconds. And now it should start ramping down. Oh, my internet connection is unstable here. Okay, that's a problem. Okay. So there we go. Okay, so it's starting to ramp down now. Okay, there it goes. So it's ramping down. Now, one thing I do need to warn you about, you see this clock up here? This clock is not running at the speed that it should be going. It's been a lot more than 7 seconds since I started the button. For some reason, the Tinkercad clock is running too slowly. Okay, so now it's starting to ramp up again. And it's about 11 seconds into here is when it's ramping up. So this clock here is the clock that I want you to go by. And for some reason, Tinkercad's clock is running slower than real time. That's okay. Go by this clock here. Okay, so tell you what, let's stop the simulation and then let's start the simulation again. Okay, so I want it to take 3 seconds to ramp up. And I want it to be 3 seconds as measured by the Tinkercad clock, not 3 seconds as measured by our clock. Okay, so I've started the simulation. And so it's ramping up. So it's not yet to 3 seconds. And bingo, it just reached full. Okay, so it's almost 3 seconds, but it was a little bit less. Okay, so it ramped up a little bit faster than I wanted it to ramp. Now, when this thing gets to 6 seconds, that's when it should start ramping down. So it's at 4 seconds, 4.7 seconds. Boy, the Tinkercad clock is really running really slow. Okay, so we're almost at 6 seconds. Okay, now we're at 6 seconds. So it should start ramping down. Yep, there it goes. Okay, so it's ramping down. And when it finishes ramping down, we should be at about 9 seconds according to the Tinkercad clock. So we're at 7.3, 7.5. Okay, so it's now down to 0. And yeah, it's about 9 seconds. Okay, good. That's close enough. Okay, so I'm going to call that good. All right, you guys understand? That's what I want you to do. And I don't mind if you copy what I did. Those of you that have done this before, you know that there are other ways that you could do it. And so I would encourage you to be creative and do it those other ways. But if you have never done this before, if you didn't take the Robotics 1 class and everything that we just went over is new to you, then I'm okay if you just copy what I did. That's a good, valid way to learn. Okay, I think I'm ready to turn it off to you and let you guys go with it. But first, let me ask, are there any questions? So here, tell you what, I want you to type something in the chat box again. If you think that you know how to do this assignment, I want you to type yes in the chat box. If you have a question, then type something other than yes. And so everybody type in the chat box. I need to know. All right, I'm starting to see some answers. Keep going. I need everybody to respond. Some of you haven't responded yet. Is that because you don't want to admit that you don't know it? Or is it because you fell asleep? Do you want me to start naming names here? I mean, everybody needs to type in the chat box. Okay, so, all right, so somebody, and I won't name who it is, somebody just asked me the question, how are you supposed to figure out the coding for the first assignment? Okay, well, you can copy mine. Okay, remember I showed you the code and it was all recorded on the video. But if you want, here, I'll make it easy. Okay, here is the code for the second assignment. So if you guys want to do a quick screenshot, you can just go ahead and take a screenshot of this. This is the code that worked for me for the second assignment. So I'll give you a second while I pause here. You can take a screenshot of that if you want. But remember, this is all on the video. So you can just go back and watch the video. Okay, have you got your screenshots? Okay, so now I'm going to go back and I'm going to go back to the first assignment. And then I'll show you the my code so you can just copy my code. Those of you that don't need the help here, those of you that know what to do, I'm okay with you just saying bye. You can go ahead and type bye in the chat box and head off. You don't need to wait for me. Okay, so here's my 5-speed motor controller. So let me click on Tinker that. And let me, let's see, I should sing a different song. Anybody know any good songs we could sing while we wait for Tinkercad to warm up here? Okay. Boy, it is really annoyingly slow today. Here we go. All right, so I'll open up the code. And let me slide this over so we can see it a little bit better. And so, okay. All right. So go ahead and take a screenshot of that. Now, this is just the first half of the code, but they all follow the same pattern. Okay, so take a screenshot of that. And if you want, I can slide it up, but you see, it's the same thing really. Oh, the one thing, oh, this is good. The one thing that I didn't talk about, look what I've got down at the bottom of the code here. This is important. Okay. This right here. If I didn't include that, then when I push a button and the Arduino tells the motor to start running, the motor would never stop running. So I need to have a command in here that tells the motor to stop running at some point. But I'd like it to run for maybe at least a half a second. Okay. So I don't want it to stop immediately when I let go of the button, because there are some problems that we could run into there. So what I'm going to do is, after I let go of the button, the Arduino, I want it to wait for a half a second, and then it will turn off pin 6. Okay, so hopefully that answers your question. So go ahead and take a screenshot of that if you'd like. Let me move it down a little bit so you can see more. Okay, so you should be good now. And you've got 15 minutes left. Those of you who have done this before, 15 minutes is probably enough to do the job. Those of you who've never done it before, okay, it might take more than 15 to do it, but you should be good. Okay, so it looks like everybody's good. All right, I will tell you what, I'm going to end the recording just in case you had a question that you didn't want to ask because you were embarrassed. Or I'll turn off the recording and then we can talk without fear of embarrassment.